Assumptions for chi-square test of independence and goodness of fit test. Chi-square test is a statistical method that can be used to determine whether there is a significant association between two categorical variables, or whether an observed data fits an expected distribution. So there are two main types of chi-square test. The first one is the chi-square test of independence. The second test is the chi-square goodness of fit test. So the chi-square test of independence will be used to determine whether the two categorical variables are independent or unrelated in a contingency table. So the data are arranged into a contingency table. The chi-square goodness of fit test will be used or performed to determine how well the observed distribution of a single categorical variable fit an expected distribution. So the hypothesis to generate to perform chi-square test depend on the type of the test. So the hypothesis, the null hypothesis, will be the variable are independent for the independence test, or the observed distribution matches the expected for the goodness of fit test. The alternative hypothesis is that the two variables are dependent, or for the goodness of fit test is that the observed distribution does not match expected. When to use the chi-square test: when the data are categorical, to test the two categorical variables are independent, then test of independence will be used. To determine if the observed distribution fit an expected distribution, then the goodness of fit test will be used. So what are the assumptions, and why do we have to take them in consideration before performing a statistical test? Assumptions are certain conditions about the data that must be met prior to performing any statistical test to generate valid and reliable result. Every statistical test have set of assumptions. Violation of some of these assumptions will lead to unreliable findings from the statistical test and incorrect conclusions. So, chi-square assumptions, the assumptions that have to be fulfilled for chi-square, whether goodness of fit test or test of independence, are: the data has to be categorical, independence of observation, expected frequency equal to or greater than 5, random sampling, adequate sample size, and mutual exclusive categories. So the first assumption states that the data has to be categorical data. Categorical data are data in a form of frequencies or count. Variable should be categorical. The variable can be ordinal or nominal. Ordinal data is categorical data with order in it. Nominal data, data that are categorical and no order in it. No continuous scale, no numerical data, and the data are made up of two variables, which consist of two or more independent categorical groups. The second assumption is that independence of observations. Each observation or data point should be independent of another. The third assumption is that expected frequency, each cells or category in the contingency table should have an expected frequency of at least 5. So if the expected frequency are less than, or frequencies are less than 5, then Fisher exact test is an alternative test suitable for these conditions to use. The fourth assumption is that random sampling, so data collected via random sampling from the population. And the fifth assumption is adequate sample size. The sample size should be large enough to detect an effect or difference. A small sample size may lead to unreliable results or failure to detect a statistical significant difference. And finally, the last assumption is mutually exclusive categories. The categories should be mutually exclusive. Each observation is assigned to only one category. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovie, Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovie, Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.